Listen while I list the physical properties of sulfur. Sulfur is almost tasteless and odorless. It is a poor conductor of heat and electricity. Now these are the general physical properties of sulfur. Let's compare the physical properties of different allotropic forms of sulfur. Rhombic sulfur is an opaque lemon yellow colored crystalline solid. Monoclinic sulfur is a wax colored transparent crystalline solid. Plastic sulfur is a brown colored solid mass. Now what about their melting points? Melting point of rhombic sulfur is 112.8 degrees Celsius. The melting point of monoclinic sulfur is 119 degrees Celsius. Plastic sulfur has no sharp melting point. Let's look at their gravities. Rhombic, monoclinic and plastic sulfur have 2.06, 1.96 and 1.95 respectively. All of these allotropic forms are insoluble in water. Rhombic and monoclinic forms are soluble in carbon disulfide, whereas plastic sulfur is insoluble in carbon disulfide. Rhombic sulfur is also the most stable form, which means monoclinic sulfur and plastic sulfur are unstable. Molecular structure of rhombic sulfur contains a ring of 8 atoms. The molecular structure of monoclinic sulfur also contains a ring of 8 atoms. The molecular structure of plastic sulfur contains a chain of 8 atoms of sulfur. Wow, we have learnt some good details. I'm sure you need a break from the theory and want to do some experiments. Let's head to the lab and do an experiment to observe what heat can do to sulfur. Take some sulfur in a hard glass test tube and heat it gently, rotating the test tube. You will find very interesting changes. The following changes are observed. The lemon yellow colored solid melts at 119 degrees Celsius to a clear amber colored liquid which flows freely. As the temperature increases, the color of molten sulfur becomes increasingly darker and suddenly becomes very viscose at about 160 degrees Celsius, and it would not flow out even when the test tube is inverted. At still higher temperature, that is at 230 degrees Celsius and above, the viscous liquid becomes mobile. At this stage, its color is dark reddish brown. At 444 degrees Celsius, the liquid sulfur boils, giving off light orange colored sulfur vapor. The vapor condenses directly to a yellow solid on a cold surface. The powdery yellow sublimate of sulfur thus formed is called flowers of sulfur. What happens when the temperature is reversed? These changes occur in the reverse sequence. Now let's learn about the chemical properties of sulfur. But to know this, we must go to the chemistry lab and do some more experiments. Reaction with oxygen. See a deflagrating spoon. Take a pinch of sulfur in the spoon. Now let's burn it. Wow, it's burning with a blue flame. Look, it's forming a colorless gas. This is acidified potassium dichromate solution. Dip a small piece of filter paper in the solution. Oh, it turns green. Did you figure out how it turned green? And what was that gas that formed? Not so much of an idea, right? Let's learn some more then. The gas formed is sulfur dioxide. That is, sulfur plus O2 will give you SO2. Sulfur dioxide reacts with moisture to form sulfurous acid. This again reacts with water to form H2SO4. H2SO4 reacts with orange colored acidified potassium dichromate solution to give a green colored chromatic salt and colorless potassium sulfate. Chromium sulfate, that is Cr2SO4 3, is green in color. Reaction with hydrogen. Hey, Tina is here in the kitchen to have a glass of water. What a foul smell. The egg is rotten. What in the egg is causing the bad smell? You know eggs contain sulfur. This sulfur combines with hydrogen to form hydrogen sulfide. It is this hydrogen sulfide that causes foul smell. Now, to test the presence of hydrogen sulfide gas, let's do another simple experiment. Soak a filter paper in lead acetate and take it out. A black stain of lead sulfide forms on the filter paper. It is a test for H2S gas. Let's take a look at another experiment to see how sulfur reacts with metals. Reaction with mercury. See this mortar? It contains a drop of mercury. Now let's add some sulfur powder. Grind it well. See, a black powder is formed. You know what this is? It is mercuric sulfide, which is black in color. That is, Hg plus S will give you HgS. We will first look at the reaction with zinc. This experiment is interesting and funny. I'm already excited to see how it goes. Let's go then. Hold on. Let's go to a dark room. Place a watch glass on the tripod stand. Drop a little zinc powder and sulfur powder on the watch glass. Ignite the mixture. See, it's burning with a green flame. Wow! See a shower of white flakes. How are these white flakes formed? Zinc reacts with sulfur, giving white flakes of zinc sulfide. That is, Zn plus S will give you ZnS. Now, let's look at another metal's reaction with sulfur. Let's pick copper and experiment. Now, take a little sulfur powder in a test tube and heat it. See, it melts and changes into brown liquid. When it boils, sulfur vapors are coming out. Now, let's insert a bright red copper wire into the vapors. Now, take out the wire. Look, it's turned black. Do you know how it turned black? It's nothing but black copper sulfide. That is, Cu plus S will give you CuS, which is copper sulfide.